All right, class. So we spent 2 class periods looking at how we can come up with our procedures for our experimental design, as well as looking at how we can kind of analyze and plot data. Our job for today is going to be to actually collect data using these constant velocity cars that have been marketed by Arbor Scientific, see if they are actually true or not when they describe them as being ones that will travel at a constant velocity. So first thing that you all are going to be doing for today is, if you've not yet chosen a lab group, you got a little bit of time here, figure out who you want to be working with for this particular lab. From there, once you kind of get with your lab group, your job is to then determine what your procedures will be. So most of this, you all have done individually back on the experimental design FRQ homework assignments. Basically, your job is kind of get together, collaborate, decide on a common game plan for your group. From there, you're going to be breaking off, and then in the back of my classroom on my desk, the constant velocity cars are packaged up in boxes. Then you have the tracks that are marked out there, basically to serve as our giant meter sticks that we have for determining the distance it will be traveling. So the key for this is you're going to be taking 2 tables, pushing them together, hopefully making sure that they are even so that way your car can go across them, run along the length of those tracks in the back. From there, once you have your data, you'll be going over kind of how you can analyze that, and eventually you'll be coming up with this kind of whiteboard presentation to display the results of the lab. So first thing, again, when we think about our question, again, you all came up with procedures here to kind of answer part A, part B. Once you're with your group, you're going to be determining out of those procedures, what is the one that your group wants to use. And then we're really going to be focusing on the now page 2. So we have this kind of blank table. It's really going to be up to you all when you're determining those procedures, figure out how do you want to organize your data. Again, one thing we try to do in physics is take multiple trials to reduce experimental uncertainty. So it's going to be up to your lab group. You'll have to decide, is this something where you want to repeat for 3 trials? Do you want to repeat it for 5, 10, 100? Right, up to you to decide how many trials you want to do. You can make use of this table and columns in any way that you think is helpful for yourself. And then there's space where you can kind of do your analysis section. So space for calculations, talking about the kind of graph that you might want to apply if you want to go that route. This stuff here will actually, though, end up on your eventual whiteboard quote-unquote presentation that you'll be given. But with this, when you go into that data collection, again, we have a meter stick more or less is marked out on those tracks itself. And then your job will be to measure time as well. So when we're thinking about that experimental design for this one, we basically say we have access to a meter stick and we have access to a stopwatch. Now with this, just to get a little bit more precision when we're looking at our stopwatch, there's this experimental device we'll use a bunch throughout the year. Have some students who I've had in the past who are going to be able to help kind of show you, talk you through that as well. But basically our job is to come up with something in which we might be able to see the motion of our object. So in this case, we have, again, our tracks laid out. You'll notice here that each of these little sticky notes that's placed onto the track is spaced at 10 centimeter intervals. Just kind of helps you visualize a little bit better. But if you were to record a video of this car going down the length of the track, the problem is if you just go back through the timestamps, for the iPad, it only goes up by 1 second increments. So just to be a little bit more precise, we're going to ask one of your classmates to also be holding a stopwatch that's constantly running in frame of this video. Right, so if we're to play this, we can see our car going down the track. We see our second iPad in view of the screen. And what this allows us to do is when I go back and forth and control the video forward and backwards, I can pause it when the car gets to a particular sticky note, and now I have a time that's accurate to the 100th spot. So what we'll be doing is kind of taking Again, however, whatever our increment is that you want to decide upon, right, we'll be able to kind of use this video to get much more precise data than just relying on second long intervals off the iPad video. Again, there's some students class who can kind of help you if this is potentially your first time using this sort of measurement taking technique. But basically what you'll be doing from there is, again, collecting data. Your job is to figure out how many trials you need. Again, I would use that data table for guidance. You're not required to fill the whole thing up. And then when we move into the analysis section, again, this is something that now your lab group will have a little bit of agency over. Right? Your job is going to be decide, right, how are you going to analyze all this data you might be taking? Again, is it important to look at every single 10 centimeters? Do you think you can get accurate data if you're doing every 20, every 30? Again, we'll allow you to have that kind of discussion within your lab groups. And then again, if we are doing multiple trials of data collection, right, what can we do that allows us to aggregate this data over those multiple trials? So something that you'll have to discuss within your lab group. For the final thing about how we'll actually then display the analysis of this, we oftentimes will use something that we refer to as the CER framework, or claim, evidence, reasoning. Basically, it is if we want to answer a question, we should have each of these three things somewhere within that explanation. So the very first thing, our claim, that's just going to be the answer to that scientific question that we have. Our evidence, right, there's going to be a brief summary of the data you collected. Again, you do not have to copy the entirety of that data table back onto your whiteboard presentation. If you want, you can just kind of use what would be your aggregated data. And your evidence would also include any sort of analysis that you've done. So if there were calculations you did, if there are graphs that you made, right, those would be the sorts of things that would provide evidence for us. And then our reasoning is basically going to be a written out sentence or two or three that's going to be linking our claim to the actual evidence that supports it. Right. Anytime we want to give an answer, there should be evidence backing it up. Our reasoning is kind of the interpretation of that evidence to make the argument for our particular claim. So what you're going to be doing to kind of submit for this lab, instead of doing a formal lab report or poster, you'll basically be making these whiteboard posters. So up at the front of the room, each group can grab a spare whiteboard. There should be expo markers in one of the shelves up at the front, or they also might be on the front table. But basically what we want to do at the very top left, we want to put all of your group members' names in one corner. And then the scientific question that we've been trying to answer in this lab is we want to know, does the car travel at a constant velocity? So that would be the same question for everyone. Your claim, basically we're just answering, yes, the car does travel at constant velocity, or no, it does not, depending upon how you've analyzed your data. Again, in that next little box, we want our evidence. So on the left side, basically filling out what would be the aggregated data table we've collected. On the right side next to it, we then want for our evidence either a graph that we've made. You can kind of just sketch that if you did your graphing in Excel. If you did some sort of example calculations as well, we would want that shown there. And for that example calculation, again, maybe you calculated 15 different things, only just show one as the overall example. And then the very bottom, we want your reasoning. Again, how can you link that evidence to your claim? So once you're finished with those whiteboard presentations, you can just stack them up in the back of the classroom. And I'll come in throughout this week to kind of take a look at those presentations. But again, if you do have any questions about taking measurements, we've got a couple people in the class who would be able to help you out with that, who have had experience from this from last year.